Alright, so we're going to start out this three-dimensional problem solving talk with a little bit of terminology. We got to talk about what the shadow or projections are in 3 dimensions. We use the word shadow to talk about these projections a lot because it really makes sense. So we want to find the shadow if a light is shined down directly above this. So UP would be this segment. So picture a large piece of wood or a tree branch going from P to U. Where would its shadow go? This is along the back side of the box. Its shadow would go along the bottom, and it would be going right there. Not right there. It would look like such. The shadow of UP is TU. The shadow of WP, let's get rid of this one. WP would be here. Where would its shadow be? Its shadow would be down there. WT. Pause the video and see if you can figure out what the shadows would be, the projections would be of VP and XP. So let's see how we did. First, let's draw these two in. VP, here's V to P, that's going diagonally across this box. Its shadow is going to be along the bottom, VT. XP, different color, X to P. Along the bottom, its shadow would be right there. It is going to be XT. So those are our shadows. They're always going to be along the bottom of this box. And we're going to use them to find different angles in three-dimensional figures. So now we want to find the angle between these two line segments and the base plane. So the base plane would be this rectangle on the bottom of this box. The base, it's a plane, two-dimensional figure. I want the angle between DG, so DG and the base plane. So basically I'm saying I want the angle between that and its shadow. So DG is right here, the base is HG, so the angle that I'm finding is angle DGH. That's what I'm looking for. Now we can do that with trig. The angles in this box are right angles. I know the height's 4. So opposite, adjacent, tangent. Tangent of theta equals 4 over 6. So theta is the inverse tangent. And we could approximate that without much difficulty. Now let's go to BH. Let's draw it in. BH is this one. Its shadow would be HF. So the angle that I'm looking for, the theta, or we'll use phi. Angle phi is defined as being angle BHF. And I know the opposite side. I know what is opposite angle phi. But I don't know either one of the other sides, and we're going to have to use the Pythagorean theorem to help us find HF. We looked at quite a few problems like this back when we were doing three-dimensional problem solving in the Pythagorean theorem unit. So HF is going to be, that's the hypotenuse of triangle HGF. So 6 squared plus 5 squared, square root, that's the Pythagorean theorem, equals 36 plus 25. And that is the square root of 61. Yeah, cool. So now I know the opposite side. I also know the adjacent side. And if it helps break out of the triangle now, this is 4, this is my phi, that's what I'm looking for. This is point B, H, and F. We just found this is the square root of 61. Guess what, ladies and gentlemen? We can find phi without much difficulty now. Tangent phi is 4 over square root 61. That means that phi is going to be, look, I made a rhyme. I could be a rapper. Phi is going to be the inverse tangent of 4 over square root of 61. And that's where my entertaining mad flow stops. And we can go to our calculator and get an approximate value in degrees for this angle.